Welcome to the Sorting Synth. This is the main view users first see when they log in. It's a visualizer in the form of an audio spectrogram and transport controls with record, play, loop, and stop capabilities. If we take a look at settings, we have an oscillator selector. This rotary dial gives you 4 different oscillators to choose from. And we have 12 different key signatures and major or minor for each one of these. We have 3 different octave slices to choose from and different combinations of any of those 3, as well as 4 different sorting algorithms to pick, delay and reverb, and speed controls. Let's go ahead and see what a insertion sort in the key of E major over a sine wave sounds like. Great. So now we have a wonderful sort here. Let's see what some of the different oscillators sound like. My personal favorite is the triangle waveform in the key of F minor, but the way I say this, so let's say we have bubble sort in the key of F minor, driven over triangle waveform. And let's go ahead and do all the slices here. I'll make it fast, but we're also going to play it, and then I'm going to add delay and reverb and see if we can make this sound pretty cool.
In order to understand the sorting synth a little better, let's take a look under the hood and focus on the signal chain and subsystems, first of which is the waveform and oscillator subsystem. We have waveform tables that show you visually what the waveform actually looks like. These are simply graphs and don't do anything until an oscillator moves them continuously along a period. We have 4 different waveforms available. We have a sine wave, which sounds very smooth, a triangle wave, which sounds a little rougher, a sawtooth wave that sounds like cell phone interference, and a square wave that sounds like an old arcade game. Back to the signal chain, we have a waveform being oscillated, but it's static. It doesn't change pitch, it has no rhythm or pattern. This is where we introduce the sequencer. As you can see in this example sequencer, this is a drum kit that is a pre-programmed rhythm that pushes through into a software instrument. Our user input is something similar, where a user predefines a key signature, major or minor, and octave ranges. That's then pushed into a scale generator that generates normalized values that fit the pattern of the user input. Those numbers are then shuffled out of order, sent into a user-defined sorting algorithm, and sorted back into order. However, when each number is sorted into place, it's sent into a converter that is converted into a frequency and then sent into a sound generator.
The 4 sorting algorithms available on the Sorting Synth are insertion, merge, selection, and bubble sort. Now, as a side note, insertion, selection, and bubble sort are actually suboptimal sorts. When the datasets get pretty large, they get pretty slow. Merge sort, on the other hand, stays pretty quick no matter the size of the dataset. The insertion, selection, and bubble sort were included because they introduced unique patterns and sequences and lended themselves quite nicely to the Sorting Synth as a musical sequencer. Back to our signal chain and subsystems. We have the waveform going to the oscillator and the sequencer making things interesting. And now it's time for the mixer to join everything together. This is a physical mixing board. We can see it has a lot of knobs and faders and things like that. And so when we insert the oscillator into the first channel, we can go ahead and ignore everything we're not using, so we can pay attention to it a little bit better. We can see that this first channel has its own little volume fader which we give to the user. This allows the user to adjust the channel volume without altering the device's volume itself. The user also has delay and reverb effects available to them, just like they would on this mixing board. Mixers have this wonderful feature of having multiple outputs. So one of our outputs goes to the visualizer, so we can graph the audio amplitude, frequency, and time series on a graph. One of the outputs goes to a recording node, so we can record the audio and save it to a device. And one of the outputs, the main output, goes to the audio engine, which I won't go too in-depth about because we didn't build it. It was powered by AudioKit. But you can go to audiokitpro.com or audiokit.io to view a bunch of examples, tutorials, and the documentation about this really cool open source library, which I highly recommend.
Next, we can hear how the sorting synth lends itself nicely to an existing track we used, for example, Radiohead's aptly titled Everything in Its Right Place.
And now, here are some musicians' thoughts on Sorting Synth.